Sometimes we want to be able to solve systems of equations using substitution. This is a really useful method to know because it works when we have systems that are not linear as well. We're going to solve one of our equations for one of the variables. Now it really doesn't matter if you solve for the x or the y, if you use the first or the second equation. My goal here with this variable that I'm going to solve for in the first step is to look for an easy one, a plain x or a plain y. That's all I really care about. I don't want to have to divide and potentially get fractions. Then we'll substitute that into the other equation and solve. Then we'll substitute the answer to solve for the first. Okay, it's sometimes easier just to see it walk through. So let's go through this example. We've got these two equations and I need to solve one of them for one of the variables. I look for an easy one here, this plain y. I can quickly solve the second equation for y by adding y over and then adding the 3 to the other side and get y equals 2x plus 3. Now it's called a substitution method because I'm going to take this expression and substitute it in for y in the first equation that we didn't use. So we get 3x plus 5 times the entire quantity. Make sure you use your parentheses, 2x plus 3, and that needs to equal 2. Distribute, collect your like terms, and solve to get x equals -1. Now that's only half of the solution. We need y as well. We need an ordered pair, so we're going to take this and we're going to substitute it. I don't quite go back to the beginning. I go right back here where I had my y equals, and I plug it in and I say 2 times the -1 plus 3 would be 1. And so my ordered pair final answer is the xy, -1, 1. Now I'm going to double check. -1 times 3 is -3, plus 5 times 1 plus 5. -3 plus 5, yes, that's 2. Same thing down here. Plug it in. -2 minus 1 would be -3. Always check your answers.